All right, welcome everybody. Good seeing everyone in person. Thanks for dealing with my illness 2 weeks ago. I'm feeling slightly better, I think. We'll see. Hopefully, I don't have a coughing fit in the middle of lectures today. Was everyone able to at least produce a JSON file from like the last class? No? Okay. Well, you'll still have time to do it this week. I mean, honestly, we're going to just update that file over and over and over again over the next 7 weeks. So I would say definitely try to do it the next day or two, because if you run into issues like we ran into, like we can resolve it together. Because if you aren't able to produce that JSON file, you basically won't be able to like follow the rest of the class. Because the whole deal is we're going to take that JSON file, pull all the links out of it, and then apply all of our AI ML tools to it, and then write back to that JSON file. So it's pretty important that we have that capability. Also, I mean, I would say by the end of class, by the end of week 7, it would be ideal to have like a couple hours of video put into your database. If you're not there yet, that's fine. Again, you'll sort of see that this process, you can just sort of go through the steps over and over and over again. So we'll refer back to those week 1 and week 2 or week 1 videos where we'll sort of chop a video up into pieces. We'll then add it to our database, and then we'll go through the rest of the steps. So again, I would say, like, over the next weeks, you'll probably just want to keep building up your data set as you work through things. Based on some of the feedback I heard last week, I am going to make some slight modifications to the class. We will do a week of generative video. I know people are interested in that topic. It's something that's still changing quite a lot right now. Maybe by week 5, OpenAI's tool will be open source, or like at least available to people. And we could look at that. So not really sure what we're going to cover in that just yet, but we'll get to it. We've got 4 more weeks before I need to figure that out. So we will do some generative video stuff. That might be applying a consistent style to the videos we like, the data set we make. It might be making new video that we can add to our data set, that sort of thing. So we'll figure that out. What that also means is I've got to sort of squeeze 2 weeks into one. So next week, I'm actually going to squeeze a bunch of stuff in together. So we'll talk about like content detection as well as body detection. That likely means that like I'll do a very cursory overview of both topics, but I have a bunch of recording tutorials on like the nitty gritty of different ways to apply detection to our video system. So what I will probably imagine is some of you will only care about sort of like a very high level idea, or want to only run one tool. Some of you might have an idea for another project you want to run like 10 of the tools. So in that case, like the tutorials will be there, but I won't cover them in class. So it'll kind of be up to you to figure out what you're interested in, and then watch a tutorial, and then ask me any questions you have there. Likewise, for this week, I have a lot of material for this week, and I've sort of cut out some stuff just so we fit into the allotted time for class. But there are links to tutorials there as well if you're really interested in a topic, especially around code. Like I've got a whole thing on FFmpeg, which is the tool we'll sort of use here. But I could teach a whole class on FFmpeg very easily. So therefore, I won't cover all of that material in this class. But I do have a bunch of links to classes I've taught previously or tutorials I've taught previously if you're really interested in that code. Again, for this class, all the code is going to be pre-written for you by me, so you don't need to worry about all of that stuff. But if you are interested in it and want to learn more, like I will always happily provide links to that sort of stuff. Yeah, so that's it for sort of the updates to the course structure. So this week, we're going to look at what I would describe as visual analysis tools. This will be stuff around, how video formats work, how frames per second, how duration works, those sort of things. So it'll be non-content. It'll be sort of be like the structure of the video, we might call structural analysis. And then next week, we'll get into sort of what's in the video. And then from there, we'll do some other stuff. So I think by like week 3.5, week 4, we'll actually have our like data set built up, and then we'll sort of do fun things with that data set. So every week I like to provide a little bit of inspiration about like some interesting projects that other artists do and make, just to give you sort of an idea that this isn't just me making shit up. It's sort of a long running study or area of video art. It's from an artist by the name of Greg Bierman. Exactly what video samples they're using, but this is essentially a large projection piece where they are essentially chopping up existing video. And one of the things about Greg Bierman, you can find some of his other work online. Does a lot with sort of the sound, the diegetic sound of the pieces and putting rhythms out of those.
We could find out what he meant by his last words. Then he was done. We could find out what he meant by his last words. Then he was done.
So we won't watch all this, but it's linked to in the syllabus if you want to check it out. But Greg Bierman does a bunch of work with found video. I think there's one that's like using the sound of music and sort of like turning that into like this very weird noise landscape by sort of chopping up the individual sounds and the individual visual video clips. Really cool work. I would definitely recommend checking him out if you're interested in this sort of stuff. But this again is sort of like, you can see like repetition, using the same clips over and over again. Like those are things we'll start to explore in this class as well. But first we need to sort of build up our data set of materials and then work off that. So often a common question I get around this is also like, I tend to teach this class as like your practice solo because that's how I approach it. Like this is the work I do in my practice. But for many of you, like you won't be a video artist, you'll want to integrate these tools into other things that you use in your practice. So that's just a little bit about like how you're going to do that. So like in this course, we're going to look just at this video data set and just use that as sort of its own material. But I would imagine for many of you, this is a way into getting material for other pieces, right? Maybe you're doing stuff in Touch Designer or you're importing video into a glitch art program, right? But you need samples and that sort of thing. So don't think about this as like purely like this is the only way to use this stuff, especially on the ML side. This is really about, hey, how would I classify a bunch of video clips that I can then use in future projects, whether it's VJing or an art installation, those sort of things. And I would say like the interesting part of this is like, I'm going to try to do like a survey, like just a bunch of things, but some of you may find like you really just like one slice of this and you're going to want to focus on just that one slice. And that's totally a reasonable way to approach this. Like, you know, you might only decide like, I only want the body detection stuff for, you know, whatever tools, whatever ideas I'm using here. Also, just to be blunt, like most of these machine learning tools are pretty imperfect today. I think that's kind of interesting. Or like, you know, part of being a media artist is sort of highlighting where technology sucks in addition to where it's really cool. And I think we will definitely see places where these tools are way less, I don't know, perfect than like lots of the AI hype people will want to tell you, right? They're like, oh, you can do all this stuff today by just feeding this into ChatGPT, and you're going to find that like, you know, 3 times out of 10, like it doesn't actually do what you think it is going to do. And trying to solve for those errors is a whole other thing, but also like, I think there's something interesting in keeping the imperfections and sort of highlighting those. Your other option is to take it into a video editing tool or take it into, you know, other artistic tools you might use and actually polish them and clean them up. So for example, that video I showed last week of the kiss, one of the things we'll find with that Pi-Scene Detect tool is it doesn't work very well when there is a fade, when there's a crossfade between 2 clips. And because of that, like, you have to decide, well, am I just going to keep that like crossfaded clip, even though it might not actually be correct for what I'm trying to do? In my case, I actually went and edited each one of those out. So I like cut them to the right scenes manually. Now, obviously that took me a day or 2 to do, but doing everything manually would have taken me months. So kind of combining the tools saved me a little bit of time and efficiency. And quite honestly, like most of these tools will get you part of the way to your sort of concept, but you'll still need to do a lot of manual stuff to get it over the line. So for the KISS, the way that works is it gives you sort of, when I ask for, hey, how likely does this scene have someone kissing in it? I can sort of set a threshold and say like, you know, give me anything where the machine learning model thinks it's 50% or more. Usually then when I get those, there's a bunch of stuff that isn't correct and I have to go in and manually remove those. So again, I went through that process of manually removing stuff. We'll talk about this more as we get further into the class, but like, just know that like, this is not a perfect art form. This isn't going to get you everything that you want immediately. The goal is to get you much, much further than you could manually. And then you're still going to have to do like a manual layer on top of that if you want to. But sometimes you also keep the imperfections to kind of highlight how these tools really work or quote unquote think. I mentioned this class will be using FFmpeg quite a lot. We already used FFmpeg in week 1 when we, I think we were converting some of the files into other formats. We'll also look this week at how do we combine files of different scales and different things, that sort of thing. I've got most of that stuff already written, and it is in a bunch of notebooks. If you are interested in using FFmpeg in your own practice, I do have like a whole video series on using FFmpeg in addition to this like very brief intro. For time, I won't cover it today. But if you are interested, like watch that stuff and if you have any questions, I'm happy to answer that. FFmpeg is a command line tool. It's honestly what a lot of companies use under the hood for all their video tools. So if you're converting stuff in Premiere, it's likely using FFmpeg behind the scenes. And it's a really powerful Swiss Army knife kind of thing for video, but it's also like the syntax for it is completely bonkers and makes no sense. So a lot of the videos I try to do, I try to like decipher like how this stuff works. But if you are interested in it, there's a bunch of material here and on my website or on my YouTube channel if you're interested in playing with it more. I think it's a really cool tool. And it's really powerful and it's purely command line. So if you are not like an interface person or you want to do stuff on a server that you can then feed back into other systems without needing a GUI, it's pretty cool. All right, so this week we are going to look at film analysis tools. So this is sort of what I describe as like anything outside of what is in the content of the video itself, right? So like this won't be like what's happening in the scene. It'll be more like what's going on with this video file itself. So we'll look at stuff like duration. So how long does our clip last? Dimensions. What are the dimensions of our clip? Frame rate, which is how many frames per second are we seeing? And then we'll get into some color stuff, and then we might, depending on how much time we have left, we might get into shot types. If I had to guess, I'll be able to explain what shot types are for those of you unfamiliar, and then I can point you to the tutorial on how to run that model. But I doubt we'll actually get to demo it together just based on time so far. Before we jump into this, like there's kind of this like interesting sort of dilemma we're going to face as we go through a lot of this tooling over the next couple weeks. So obviously we cut up our video into a bunch of clips, right? So those clips are 3 seconds, 5 seconds, 10 seconds long. But the way a video file works, I assume everyone is aware of this, but the way a video file works is actually a sequence of single frames images that are then ran at a certain speed. And our brain is sort of like, oh, that's a video, because we kind of see the motion, we can make up like how it works. So one of the questions we're going to have as we run these tools is, well, should we run this machine learning tool on the clip or should we run it on the frame? And we're actually going to find that sometimes it makes more sense to run it on a clip level. Sometimes it makes more sense to run it on the frame. The reason you might run it on a clip is like, this is actually video, right? It's something in motion. So there's a case where we want to actually assess what's happening in the motion of the scene, right? Are things moving left to right? Are objects entering and leaving the space? Those sort of things. So in the case of where we really want to focus on motion and understand the motion, we want to make sure that we find a tool that is able to assess the motion within the clip, which means we need to actually operate on the clip level. The biggest challenge of that today is that most machine learning tools work on a frame level. So there are actually like a lack of decent models. Now, this is changing every day as more and more people work on video tools, as video becomes more of the sort of predominant space that people are moving into. We're seeing more and more models, and there might even be some new ones this month that I need to start looking at to maybe integrate into this class. But in general, there's less. Yeah, go for it.
How many do these techniques also work on stills?
Yeah, so this is also the thing is if you have stills, I would probably recommend working on the frame level. But yes, many of these tools actually are meant for stills. And what we're going to do is sort of fake it into working for clips by sort of operating on a number of different frames within the sequence.
If we wanted to work on stills, is it a
Yeah, it would probably work fine. We'll have to figure out like we would need to sort of modify the way we built our JSON file, but it would certainly work still with stills as well. The other downside of working on the clips level is, as you can imagine, it's more data to process. So it ends up being a slower processing time. So for a lot of this stuff we're going to do in this class, when I build my data sets are 250 hours long, usually like around that length. It might take days for me to actually process all that material because of GPUs, models, like all this sort of stuff. It just takes a while to process this stuff. So the downside is also like if someone's like, hey, I want you to work on this project, I need it back in a week. You might have to change how you operate on stuff based on the amount of processing time you can actually achieve. The way I built this file or the way I built the setup is like, it's a static single file database. So you can't do like multi-threading because we would have to like write back and forth, and it's like beyond my technical skills. So, at like probably at like a company, like at a motion graphics firm or like at a like production house, they probably have like an actual database where you could even do multi like threading sort of stuff with these processes. I'm not at that level, and honestly, I don't feel like setting up a server for this class or anything like that. So we're going to just operate sort of on the assumption like, okay, one of these processes has to run at one time and write back to the JSON file in that structure. So there are ways to move faster if you really had to, but for the most part, these tools are going to be quite slow because we're going to be operating on so much data over time. So what I recommend for this class, especially starting probably this week, is you'll probably want to like start tomorrow, like actually running these tools. A lot of these tools can be run behind, like basically in the background. So like let it run overnight, check on it in the morning, keep it running or whatever. So there are lots of opportunities there to like the cool thing, other thing I like about this process is it's kind of hands off in a lot of ways. You just let it run and then you come back and check on it. For a lot of people, that's kind of not how they like to work on art, and I totally understand that. But this process does take time, and you're gonna have to build that time into like planning ahead, essentially. When I'm going to operate on the frame level, it's often something that's like easier to assess, right? So this would be like I just maybe it's a static scene where there isn't a lot of motion on it. And you just want to assess like what's in the scene, or in the case of something like just trying to determine I don't know, the dimensions of a file or something like that. These are pretty easy to do. Like I said, these are actually like often tools that are meant for static images, whether it's computer vision or other things. So there are a lot more models available for these tools today, and we'll look at different versions of each of these tools as we go through the class. And then, like I said, one of the things we can kind of hack into this is we can actually do some clip level analysis, but often what that will mean is we'll have to convert the clip into single video frames, and then we'll operate over those in series. And that can mean that it's faster processing if that means we're skipping like every other frame, right? Or if we're skipping every 5 frames. The downside of some of these like sort of frame level tools is obviously they don't think about stuff in motion. And anything where, say, you only grab the most middle frame of your video clip, it might miss changes that are happening outside of those. So as we go through this, we'll have to sort of figure out like what's most important or most appropriate for what we're trying to achieve. So like, for example, this is a really great example of like, if we were to only do frame level analysis on this image, like it would probably be good if we were doing stuff like color analysis, right? I can imagine that our like predominant purple color isn't going to change across our clip. But if I were trying to figure out like, is this person jumping up or are they falling down in this clip? I wouldn't know, right? So this is a thing where we have to find the model that fits the need that we have here. If I want to understand the motion, I need to find a model that actually can understand the motion of this clip, whether it's someone going up and down or just up and then stops or down and then stops. But if I want to do stuff like color analysis on just the most predominant part of the graphic, then maybe I could get away with using that on this. As I mentioned, there's a lot of new tools coming out every month, every week. I'll probably even check. I try to check like every week on like if there's any new updates or faster things that are worth exploring. So far for this week, I didn't really find a lot of stuff. That's because we're not really digging into the ML tools this week. Next week, we'll probably be doing more machine learning stuff. This is going to be a little bit more sort of, well, still machine learning, but it's like more basic machine learning. So let's talk about a couple of these things. So what we'll do is we'll go through sort of some of the topics, and then we'll open up a notebook and look at how to actually run that on our examples, just so we can sort of see how things work. So duration, I think this one is probably fairly obvious for everyone. But what's actually interesting, and I will show some examples of this, I actually think this is really helpful if you're trying to understand like a video material you like. So maybe you found a video or a film that you really like that you want to sort of understand more and be like, why do I like it? Or like, what's interesting about the pacing, right? Often when you're making films, someone will say like, oh, if you were paced this like this other film, I think it would feel better, right? You might be like, well, what does that mean? Does that mean story? Does that mean actual clip editing? That sort of thing. So I actually find that like some of the duration tools we'll look at here are kind of interesting in evaluating and understanding what's going on in a whole sequence. So with the tools we're going to use, duration will always be expressed in seconds. So it might be a decimal, maybe 2.2 seconds. It might be 3 seconds. It might be, if it's more than a minute long, it might be 145 seconds, right? That would be 2 minutes, 25 seconds. But in these tools, it's always expressed in seconds. So here's an example of like an interesting sort of like film analysis tool. So imagine that every time it switches between black and white in this scene, these are cuts. I don't know if anyone's ever seen either of these movies, but I don't even remember why I grabbed these two, but it was just something I was doing. So if we look at the top one, has anyone seen Pitch Black before? No, okay. Can you imagine what type of movie that might be?
Black and white.
Yeah, sorry. So black and white. Sorry. So we're looking at wow, 2000 movie that's black and white. Okay, I'm not that old. So remember that a black and white is the switch between a cut. So this is not color analysis. This is a duration analysis, meaning one clip is this length, and then it's this length, and then it's this length, and it's this length. Someone said action. So action is definitely the kind of movie that we're looking at here, right? And you can kind of see that by like a lot of sequences flickering back and forth, right? So lots of cuts in this scene. Whereas Punch Drunk Love, has anyone seen Punch Drunk Love? It's sort of a romance comedy film, but it's much more sort of slow paced. So you can kind of see that in the way the sequences are cut, right? Long scenes. I think this was shot on like 35. So those are shot on film. Usually a movie that's been shot on film tends to have longer takes because it's hard to do edits. So you can actually even see how the sequences here are much, much longer. Now there are still little sequences where there's cuts, and I bet if I were to look here, these would probably be like dialogue scenes where they might be cutting back and forth between two people talking. But this is kind of an interesting, if you were just to do this in like a film theory class, like this alone would be really helpful, right? You might take 10 films and say, how do these 10 films differ from each other, or how are they similar? And you might just look at the structural like cut analysis of the way they're built. This is fairly simple once we are able to assess all the duration of our clips, right? So we use the Pi Scene Detect tool to find all of our cuts. We then cut them all up, and then we assess the duration of each clip, and then we can rebuild our sequence here using that duration. So this might even be good for like a critical media art sort of installation, right? You might even say like, how does film of today, or how do films from like blockbuster Hollywood action sequences compare to like documentaries, right? Those sort of things. So this would be something that you might use in like a critical analysis sort of sequence, but I think it's still helpful to look at because you might also want to put in your favorite movie and be like, why do I like my own favorite movie, right? Like, what are the clips happening here that I sort of find the pacing interesting? What's going on here? Oh, there we go. What is this video? Oh, okay, sorry. This is a video I made a couple years ago. This again, I don't think I talked about scream scenes a week or two ago. This is built up of all four scenes. Verse length. So basically what it does is it builds up over time where take the longest clips and sequence them in order. So as we get towards the end of the film, it gets faster and faster. And at the end, it's almost like individual little frames, right? Again, you can think about this as pacing of horror films where you're like getting scarier and scarier as it gets crazier and crazier, whatever. But that's sort of the idea. So again, a little simple ways to sort of use these tools in more, more artistic fashion. Why, of course, do I not have links here? Let me see where my links went off to. There we go. Okay, cool. So there are a couple things we can look at here. So let's take a look at the first notebook. I'll paste these in our Discord as well, so we have them. So we're going to start by looking at this tool called FFprobe. FFprobe is a part of the packages of FFmpeg. Again, these are all just command line tools that allow you to access video metadata essentially for FFprobe. So just like we did last week, the first thing we're going to do is we're going to just check to make sure we're not running a GPU, so we're not burning through credits. And actually, I need to switch my account here real quick.
Can I ask a question?
Yeah, please. Yeah.
Is it necessary to save each of the notebooks? So I know we can't save on your notebooks.
Yeah.
And then you said if we do choose to go ahead and like save a copy of it on our own drive, that if you make updates to your notebook, we won't
Correct, yeah.
So when we're doing these work, should we save a copy or should we just, because everything still ends up on the drive anyway?
Yeah, yeah.
But we won't have the copy of the notebook. I don't.
Yeah,
I've done that,
yeah.
I don't know if that was necessary.
I don't know that it is necessary. I will try to tell everyone when I do make updates in case you did save a copy. The only reason why I think you might want to save a copy for yourself is that sometimes there are places in here where you're going to need to make edits. For example, like sometimes you're going to want to run this multiple times. If you used a different path than I did, you might just want to like save it so you have your own path here, right? Anytime you open this, this will default to whatever path I put in. And that's the only case where it might be kind of annoying or you'll forget about that sort of thing. But I would say in general, you probably don't need to save copies of it. So I think you'll probably be fine without doing it. But if you want to make more notes than I have here for yourself, then yes, by all means do that. Just gonna connect to Drive here. I also just found out that they're changing how NYU's drive access like in a year. Do you guys know about this? So right now you have unlimited drive access, but I guess in 2025, they're changing everyone's access to only be max of 20 gigabytes, which means I won't be teaching this class again. So, so I don't know. I mean, I think most of you are finishing this year, so maybe that won't be a big deal for you, but I was kind of like, oh, that's going to fuck up my class really hard next year. So enjoy the unlimited space you have today.
I think it's 20.
Yeah.
Today, really? Oh shit. Then okay, then this might be interesting. Oh well, all right. Well, then that might also everyone gets their own space. I mean, I have 650 terabytes.
650 terabytes.
Yeah.
Wow.
No idea. I mean, I've been here working at NYU for 4 years now. Maybe I just got grandfathered into some system. But I got an email this week where it's basically like, yeah, we're shutting off your unlimited access. And I was like, that's gonna actually kind of like screw up my classes. So if you guys do have limited space, like let me know and we can figure out a way for you to like, I don't know, transfer stuff over to mine. It's crazy that even within the class, there are people with different space amounts. Okay. All right. All right. We'll figure this out together. Yeah. Okay. Well, that's good for me to know. I will figure out how to work with everyone's. You're gonna create a lot of video files tend to be very large in size. So we'll have to figure this out together. I'll give that some thought this week and try to come up with a better solution. You can like, I know there's a way for me to sort of grab your files and put them on my server or on my drive. So maybe I'll investigate that this week and we can talk about basically like finding some way for you to like basically run off my system. Unfortunately, Drive used to let you actually like use someone else's account. But for purely obviously security reasons, they like stopped letting you do that. Okay, anyway, go ahead. Yeah.
Is there a way to like an easy way to do this on like Jupyter notebooks that we can just store on?
Yes, these are basic Jupyter notebooks, so you could download them and run them. The only thing you'll have to do is change some of the file pathing. I will also look at that this week. Maybe I'll figure out how to basically create regular Jupyter notebooks for everybody as well. That would also work. Yeah, we can figure some of that out as well. Okay, so I've just connected to my Google Drive here, and in my drive, I should have all my files, ITP Algo Film, and in here I've got clips. So usually the way that I work through these tutorials is I'll run this example on a single file just so you see what it looks like, and then we'll basically operate on every file within our JSON data set. So the first thing we can do is let's just grab like a regular, like a single clip here, maybe a single video. So let's grab that trailer we looked at from last week. So go to copy path. And if you just put that path in here after the -i, and then we run this, you'll see it spits out like a bunch of sort of, hard to interpret code. This is all of the metadata that is applied to this video file. I skip over pretty much all this stuff because I kind of know what's going on, but not really. Mostly what I look for is under the stream setting. You'll see under stream, there is a video and an audio. So a video file contains obviously both video and audio. So those are set up as what we call streams. Inside of that video file, or on that same line as the video file, there is then this other thing, which is like, this is the color format. This is the dimensions of the video, right? So obviously this is 1920 by 1080, which is a traditional 16 by 9 video format that is HD or 1080p. You will see the video frame rate is 23.98 frames per second. And is there anything else I care about in here? Probably not. So what we want to do is actually want to extract these values and be able to understand from our video like what these are. Unfortunately, FMPEG has no way to really do extraction, so we end up having to use some like crazy JSON code here. Again, don't worry about what the code says, but essentially what this is going to do is this is going to allow us to extract that data from this command. So for this, you're going to want to hit play up here. This is all just code. All this does is it saves these functions into our runtime. Often what will happen with people who have not used notebooks before, they'll skip a line that doesn't look like it has to have anything changed in it. But if you skip this cell, it won't actually save your functions and it won't be able to run those functions later. So make sure you run pretty much any notebooks are set to run just like top to bottom. So just hit play in each cell as you go down it. So nothing happens here because all we're doing is we're saving the function into our runtime. But then if I come in here and I copy this path again, and I just change this, go ahead, yeah.
So there's a student on the Zoom and they said if you could share the screen with me slides.
Oh shit, I'm so sorry. Yeah. Sorry about that. Yes, I can. Yeah, of course, you're just seeing a blurry screen. Sorry about that. Okay. So with this, we're going to enter in our path to our video file here. You don't really need to worry about following along with this part because we're going to do everything actually in here in the JSON database. But we'll see when I run this command, this is going to pull apart all of this crap up here into just the lines we need, right? So we'll see our duration is for that trailer is what, about 2.5 minutes long. Our dimensions are broken up into width and then height. And then our frame rate is broken up into the frames per second. So now what we can do is we can take these functions and we can run these across our entire JSON data set. And then what we can do is we can actually save that back into our JSON file. So let's go ahead and run this here. Oh, I actually haven't run this yet. Oh yeah, I did. Okay, let me just make sure stuff's in here. Yeah, okay, so we've got stuff in there. So what we'll do then is for this, we're going to up here, just put in the path to our video clips. So that is going to be this folder. We're going to then put in the path to our JSON file. And we're going to skip this stuff. These last two things here are if you need to either, let's say you ran a command or like you broke up your video file in Piscine Detect, but used the wrong settings. Like you use black and white when you should use color or whatever. Like, so maybe it generated the wrong files. If you hit force reprocess, it'll just rerun over all of that material. And then if you only want to run this on a certain word, you can enter in the filter word, which is basically the file name. This is for speed and some stuff I've been doing, but you can kind of just ignore these two. But anyway, now we've put in the clips and the JSON path, what we can do now is we can run this. What it's going to do is it's going to load in our JSON file. And then it's going to actually, you can kind of see there's a little arrow here. You can see what it's doing as it's running. So it's going to run through every video clip we've given it and then give us these dimensions. Or give us dimensions, duration, and frames per second.
Well, that's running.
Yeah.
Ask about glob.glob.
Yeah, what is glob.glob? Glob.glob is, where are you seeing that?
like near the top of
Yes.
the cell that you're on right now.
Yep,
Like,
cool.
Searching through
Yes.
like all subdirectories of clips path, and things and MP4.
Yep. Yeah, that's what that's doing. Yeah, glob is the Python like sort of, I don't even know what it stands for, but it allows you to format a search parameter. Yeah.
That would save me a lot of time on projects.
Yes.
Structures.
One thing I should mention here, however, is if you change how your folder structure is built, this might break. So the way I've set this up is you've got your clips folder, which is this path up here, and then it expects a folder inside of there, and then expects a video directly in there. So if you were to create some like subfolders in here, this would actually break. In which case I can fix it for you, but it just so you know, like there is a sort of hard built-in structure here that you need to sort of like work with. This happened with a couple of students in past classes where we didn't really capture this correctly. So yeah, just make sure that I would generally say recommend just follow my file format. If you want to do something crazy, then we might just need to talk about what you're trying to do. Okay, this finished running. It took 1 minute. And if we then look at our clips file here, we'll see we can't really look at this thing. So I put a link in our syllabus here to what's called a prettifier, which allows us to look at JSON in a readable format. You can also just save this here. You can also type in JSON pretty. Yeah, let's do this. Let me just see JSON. I might just literally pull up the link that I had. So what you'll be able to do then is you'll load data, you'll upload a file. So this is what our file looks like, right? It's kind of hard to read, but we'll see actually over here, Jesus, all the fucking ads. You can see here, however, that when we actually format this in a nice way, we can see that each of our clips is given dimensions, it's given a duration, and it's given frames per second. So now that whole process we were doing of sort of being able to take every film or every clip and be able to analyze the scene is now very easy for us. We also now have dimensions, which we'll look at in just a minute, and frames per second, which we'll also look at. So this allows us to sort of at scale work across all those videos and give us all these different parameters. So we're going to do basically over the next 4 weeks is just add to this JSON file. We're going to add like, we'll do stuff like what colors are in this video, what objects are in this video, or what dialogue is being said during this video. So we'll look at all that. We'll just build up this path here. We'll build up an object database so we can then operate on that over the future. All right. So as I mentioned, I won't cover that duration visualization tool, but there is a video already on that covers it if you're really interested in that. I just had to cut some stuff for time, so that being one of the things that got cut. There's also a notebook that allows you to do it if we want to do that. So we've got that here if you're interested in that and want to play around with it. Let me know if there's any issues, but I ran it yesterday and it worked fine. All right, so let's talk a little bit about dimensions. Dimensions of video end up being kind of complicated, especially if you want to keep the quality of your video quite high. We also talk about ratios, and this gets into like the history of film. Old film, like film used to have like some pretty set standard ratios because it was actually done on film, and that had predefined standards. So there were ratios of 4:3, which is like the very early, most common ratio for film. 16:9, which I mentioned before, that 1920 by 1080 breaks down to 16:9. That's probably the most common sort of like widescreen format. But even before that, there was this other ratio called 1.85 to 1. That's what's called the Academy ratio, which was another very popular film ratio. And then there was even one called 2.39 to 1, which was like crazy widescreen. That's probably like an anamorphic widescreen. These were sort of common sizes, and you'll still sort of see them commonly used today. However, with digital, like people crop stuff to whatever size they want nowadays. So one of the challenges here is like you're going to download a bunch of videos and you might find they all have slightly different ratios. And you're going to have to sort of figure out like, well, how do I work with this? There's also resolutions to work with, which is, on these dimensions, right, 4:3 or 16:9, if the video file is what's called 1080p, then 4:3 would actually be 1440 by 1080, whereas 16:9 would be that 1920 by 1080. I don't know what these convert to. But you've got different resolutions, right? You've scraped some old video off the web. It's like going to be 480. Then you've got 720, and you've got 1080. Now we're up to 2K, 4K, 6K, 8K. I hope no one's working off 6 or 8K video. None of this stuff is going to work. It's all going to crash our machines. But you can work off different resolutions. What I would probably recommend is if you're working with really high resolution, for this stuff, what you might want to do is actually down sample it, change it to a lower resolution, run all the processes off it, but keep track of the video file names. So then at some point you can actually like switch back to your high res version. So when we try to combine formats, which is, again, maybe what you're doing with like a collage video or more, found footage type of stuff, you've got a lot of challenges to figure out, right? So let's say we've got a really widescreen format that's quite large. Then we've got a 4:3, which is probably like, maybe 480p or something. How do you actually combine those two in a way that makes sense, right? One option is you would crop in to basically get the smallest size possible. So say your video is 1440 by 1080, but your other one is a 2K widescreen. You might crop or scale down your video and crop to the smallest dimension. That's going to give you no black edges on your video. That will give you like sort of the maximized amount of frames. The downside here is you're going to crop into your video and maybe lose some video material that you actually want to keep. Your other options are padding, which would mean you take the largest size video and then you pad around it by adding black borders around anything smaller than that. That's going to give you an interesting look in the sense that like you'll be able to immediately know when a video is low res versus not low res. But maybe that's something you want to actually play off of, right? So it will keep the highest size and then pad around everything else. And the other option is letterboxing, which is kind of a mix of the two. You take like the ratio of your largest, of your like, I don't know, most square video, and then you scale down everything to fit in there. This is what you'll commonly see because letterboxing is what most people have done in the past, especially when you converted like a really old film into like TV, you'll just letterbox into it. But these are decisions you have to make, especially when combining all your video. This is kind of like one of the challenges of, or one of the first decisions you have to make even when you're doing like video collage, that sort of thing. So here is a notebook on how we do this. So let me just copy this path again for everybody. There. Okay, so again, with most notebooks, we're just going to check to make sure we're not running a GPU. Our drive account here. Ah, shit, wrong account. So in this case, what I'm going to do is I'm going to look at a JSON file that I made previously that has thousands upon thousands of clips in it. Let's actually take this one and we'll look at this. So in this case, what we're going to do is we're just going to load this JSON file. Now you have to have already previously run that notebook we just ran, right? Because that's the one that stores all of our dimensions in it. So you have to run that and save that to your JSON file in order to run this notebook, because this is going to then grab all those dimensions and then assess our video files based on that. So if we go in here, when we run this notebook, or run this cell, this will probably take a couple minutes for me to run. Yeah. Okay. So this basically just pulled in all of the dimensions from our video, from our JSON files. And then what we can do is if we run this cell, this is going to tell us all of the dimensions that we have. So the max width for my for these files is 1920. The min width is 1920. The max height is 1080, and the min height is 1072. Now, if I actually run this, let's find a different video file here. Let's try running it on this one. Oops. So this filter, basically what it'll do is it'll filter out anything by the file name. So let's say you only want to work off of, if I look in here, let me see what my files are. Let's say I only wanted to look at the Blade Runner files here. If I put in the word Blade Runner, it's going to only filter by that. Yeah. The key for this filter is if you use it, you have to match case. So make sure everything's, in this case, lowercase, although your file names might actually be different from your folder. That's the other challenge there. Yeah. Very cool. That ran. So now let's run this again. I think we'll have a much wider range here. Yeah. So when I run this on this, you'll see we get a max width of 1920, a min width of 848, max height of 1080, and a min height of 345, 354. Wow, I can't even read today. So this is just giving us our mins and maxes, which is actually sort of what we really want to work with. We could get averages, we could get any number of things here. Our min ratio, is that min or a max ratio? I guess it's technically max ratio because it's the highest number, but it's actually just like, it says there's some really ultra widescreen stuff in this material, right? Like this is to 1. So this is actually that almost anamorphic range where it's a 2.93 to 1 ratio. So now we've got options here to combine different dimensions. So what we're going to do in this example, because I've got so many clips, I don't really want to work with every single clip. This how many clips allows us to collect a random selection of clips. So like, let's just grab 20 random clips from this. How many are even in here? Let me actually see. Selections. So this JSON file has 3,324 video clips in it. We could combine all those directly, but it's going to take forever in FFmpeg because it's so many files. So usually what I'll do is for this demo, I'll just keep it to something small. So let's actually make this like 50. So it's just going to grab 50 clips and it is going to spit out what those clips are. I don't really care what they are here, but it's just going to grab them. Then what we can do is check within this set to make sure we still have a decent range of stuff. And sure enough, I still have a pretty good range. You will notice that my min ratio actually changed because I grabbed from a smaller set of videos. So it's a little bit different there. But we can still work off this. What is this going to do? I don't think we need this. Oh, yes, we do. This is just a function that creates a temporary folder for us. So basically the way FFmpeg works is it's going to resize all of our videos and then it's going to combine them all back together. So because we don't want to operate on our original video files, we don't want to downsize those video files. We're going to get a temporary folder. We're going to do all the scaling and cropping and stuff, save those to that folder. And then we're going to, what's called concatenate. We're going to put all those videos together at the end. So we're just going to stitch them all together. So this just creates the temporary folder. We don't really need to worry about that. And then now what we're going to do is this is going to be cropping to the minimum dimensions. So what this is going to do is this is going to do this one, right? It's going to crop all of our videos to the smallest dimensions. So in the case of, where's that sound coming from? Next door? So what this is going to do is this is going to take all of our larger videos, right? So we've got stuff that's larger than this. We're probably going to scale it down to match the height. And then we're going to crop to this dimension. So I think the minimum dimensions are going to be 958 by 576. So we're going to scale everything down and crop it. So again, this will lose some of our edges on wider videos, but it's going to crop to this size. Now, again, this is all using FFmpeg as well as some other things. We don't really need to worry about the actual functions in here. Just know that like what this does, it crops it down. So we're going to go ahead and run this. Actually, I'm just going to save this to... How long is this going to take? You know what? I'm actually going to change this back to 20. I realized this is why I had 20 in the demo, because this was much faster. So let me just, how am I going to do this? Let me just stop runtime. Okay, so sorry about that. Let me just rerun some of this stuff. Ah, shit, I have to rerun this one though. All right.
Can I ask a question?
Yeah, please. Yeah.
So I see like we're like concatenating all these together.
Yep.
And you get all them combined together in a file. Is there a way to live concat them? Like if you're playing, you have a bunch of clips that are arbitrarily long, you have a clip, being able to play that while live adding to it?
I don't think so. That's where like the FF stream stuff comes into. Like there's an FF like player that does do live stuff where that's where you might do some of that. I've never played with that stuff because it's like I mostly don't work in live real-time stuff. Yeah, I think that's where you'd have to do that, but it's probably very complicated, I would imagine. Yeah, no worries. Yeah, for anyone that's interested in FFmpeg, while this all runs behind the scenes, I have a class on my YouTube channel. Oops, shit, that's the wrong place. Yeah, so I have a whole class on video art with FFmpeg where you learn to do crazy stitching of stuff like this. So there's, I think, 3 or 4 weeks, and it's also all collab notebooks. So if you want to check that out, there's a ton of stuff there. And this actually explains how FFmpeg works, which is far more than I could cover in this class. But if you are interested, you can just find that with the video art with FFmpeg. I think it's also linked at the bottom of that FFmpeg notebook. Yeah. We don't get into streaming. This is all still like basically, generating video, not real time, but you'll at least learn a lot about how FFmpeg works through that. Yeah, of course. Okay, now I think we can run this and hopefully save ourselves a little bit of time. It'll still work. So what you'll see is happening here is if I go to, is it outside my drive or does this get saved? Yeah, okay. So you'll see here that what we have is a temporary folder, and these are date stamped or time stamped. And inside them, we're saving out these individual files. Now, at the end of this function, there's a cleanup function that'll remove all of that. But because I stopped one of these early, it didn't get to that function, so it didn't actually clean up. But this will basically just create a bunch of files here locally in Drive, actually in Colab. Do the concatenation, save the concatenated file to the right place, and then delete all of this stuff so you need to worry about it.
Can you enlarge videos?
You can enlarge videos. I mean, the downside of enlarging a video in FFmpeg is it's not really going to do, it's just going to make it blurrier. It's going to make the video larger, but it will because of scaling, it won't actually do a good job of this. If you want to do like actual upresing of videos, like that's probably a machine learning tool. And there are some good ones out there. The one that I tend to use, but unfortunately you have to pay for it, is Topaz Labs. There is one called Video AI. And this actually does AI upscaling. So it actually generates new content as it scales up. And you'll find this works much better, but it is expensive. There are open source versions. I'll have to see if I can find some open source video tools. But yeah, if you want to do upscaling, I would probably recommend using an AI tool because you get better resolution out of it. FFmpeg has started building in some machine learning tools, but they're definitely not nearly as good as sort of the state of the art stuff is. Okay, so while this runs, I'll just mention in this notebook, you'll see there is one for cropping, there's one for padding, and then there's another function here for, oh, there isn't a function here. Thought there would be one for letterboxing. Interesting. I probably have one somewhere else for letterboxing if anyone wants to use it. You will see that in future sessions, we will actually turn this into a function that will then put in other notebooks. But this is just the basics of how they work. You can go ahead and play with these. And actually, very recently, I realized ChatGPT actually works really well with writing FFmpeg functions. Like I think actually one of my FFmpeg functions is incorrect or leads to an error in very weird use cases. But I was able to ask FFmpeg to fix it, or ask ChatGPT to fix it for me. And it did write correct FFmpeg. So I feel like just the fact that ChatGPT knows how to write FFmpeg commands is like a lifesaver. So if you ever are stuck, like you can always try to ask ChatGPT for it, and it usually, except for very weird edge cases where you're doing some really crazy stuff, it generally does know how to do it, which is probably better than searching for it today, because searching for it leads to all sorts of incorrect answers. So if anyone's interested in trying to write their own custom FFmpeg functions, ChatGPT is pretty good at it. Okay, so that created our cropped version. So we download this cropped version. And actually, while we've got that cropped version, let's run the padded version. So here for this version, you're gonna, or for this padded function, you're gonna give it the output path. So we're just gonna save this to our collab notebook. And then what we're gonna do is we're gonna set a max width and a max height. So again, this is, you know, what is the max size? And this will then pad around everything else. So let's actually go and look at our dimensions here. So we'll see here that our max width and our max height for this 20 random set of videos is 1920 by 1080. So let's actually use that as our dimensions. So we'll say our max width is 1080, or sorry, our max width is 1920 and our max height is 1080. And then we'll run this one. You also notice that that second temporary folder got deleted. So it did actually work. This one is just stuck there because I quit the function before it finished. So let's take a look at what that test cropped video looked like. There's a weird thing where sometimes the audio stream doesn't come over with it. I need to figure out how to fix that still. But in most cases, I'm just working off the video, so I tend to crop down. But you will see, you can clearly tell that some of this is cropped into, right? Like this scene is clearly cropped into, right? This was probably an older film, so it wasn't using this really widescreen anamorphic. But in other places, it's a little bit less clear. Like I would say this is probably the original dimensions. So it did cut everything down. And then we're still working on our padded one here. We'll compare the two when we're done. time does class run till 2:45? 2:40, okay. What else do I have to cover here? Okay, yeah, so let's keep moving while this runs in the background, because I had a lot more to cover, shit. Okay, frames per second. So frames per second is what we call the frame rate. This is how many individual frames are displayed per second. Most common frame rates are 24 and 30, 60 becoming much more common today, although if you're using video files, you tend not to find 60 frames per second because they're too, that makes the video bloat really crazy. Although I guess if you're pulling off YouTube and you might pull like some live streams down, those might be done in 60 frames per second. You'll also see 23.98 and 29.97. Those are sort of old school television formats, but they're still pretty commonly used today. Obviously 23.98 basically converts to 24 and 29.97 basically converts to 30. Now the challenge is where it gets really hard. The challenge for merging different frame rates is like really annoying. And let me show you a quick example of why that is. Usually what you have to do is some combination of dropping a frame. The problem is that once you drop a frame, anyone that watches video closely, you can kind of actually see where the frame gets dropped and it feels kind of jerky in some ways. So converting 30 frames per second to 60 frames per second is quite easy, right? You just drop every other frame. But converting 30 frames per second to 24 frames per second is actually quite tricky. The only way to do it is basically to drop a frame. And then when you play this back, it's actually not sequenced in a linear fashion, right? You're going to feel that missed frame dropped. This is why most people, when they shoot video, they determine their frame rate before they start shooting anything. They shoot everything at the exact same frame rate. With us, because we're doing some collage film weird shit, we have to figure out how to solve for this. Most often, you have to just drop a frame, and it's gonna feel kind of weird. But that's just kind of the best thing you can do. There's really, you could go from 24 to 30 by basically like sticking a static frame in here. Like basically you would just repeat this frame. You would have one frame repeated. That would work too, but again, it's still gonna feel kind of jerky. Most people just generally will take the lowest frame rate and convert everything down to that. It's smaller file size, it's a little bit easier to work with, but in general, it's like annoying. In an ideal world, you can always have like 30 frames per second or like a consistent frame rate across all your videos. In most cases, if you're just grabbing shit off the internet, it's not going to happen like that. So you have to kind of solve for this. Today, there are also machine learning models that will create interpolations, meaning they will add frames between things. In my experience, they are still pretty shitty and not necessarily worth doing, especially because to actually make this work, you actually need to generate like something like, I think 6x the amount of frames because you need to get a linear step between each thing. You actually need to create way more frames than just these frames to get it to feel smooth. And by the time you're creating that many more frames with AI tools, like the frames you're actually pulling from look like shit because they've just been like interpolated multiple times. So maybe someday that stuff will get better, but in general, like easiest way is just to convert everything to the lowest frame rate and deal with it from there. And most tools will just drop a frame. So FFmpeg, when you convert the frames, will just drop a frame. You could also potentially slow it down. If you don't want the audio, you could even convert 30 to 20 by just using every frame and just changing the speed at which it plays, but that will create a slower video. 30 to 20, yes, that'll create a slower video. Also, you could do 24 to 30, that will create a faster video. If you ever watch like old timey films and how they always look kind of like super sped up motion, that's often because they were shot at something like 12 frames per second and someone converted it to 18 and it feels faster because those frames are moving much quicker. There's a whole science beyond this that we could get into for a whole single lecture, but suffice to say, you kind of have to figure out how to deal with this. And in most cases, the easiest way to just drop the frames. Someone who's really aware of how frame rate looks will be able to tell, but because we're sort of stuck with found footage, we're gonna have to deal with what we got. The other thing you can figure out is
TVs sometimes look weird when they convert from.
Well, there's a couple of reasons why TVs look weird. Some of that is frame rate. Some of that is like what's called telecine, which is they would actually photograph film on video, and then that stuff would look kind of fucked up and messy, especially in the 90s. Like that's like everything was terrible because of that. But there's a bunch of different reasons. There's also lots of Modern TVs also do upscaling like in the TV, which isn't always great. Like there's all sorts of reasons for why stuff looks like shit. It's mostly because some engineer decided we'll do this across everything and it doesn't work for certain things, right? Yeah. You can also determine exactly how many frames are in a clip by multiplying your frame rate by your duration, right? So 1 second clip that is 24 seconds, 24 frames a second, will have 24 frames in it. When you do this with FFmpeg, you take an FFmpeg duration and you multiply it, it's often going to be off by a couple frames. So you can't really expect it to be perfect, but it will give you at least an approximation. So if you're trying to do something where you're like, you want 1,000 frames, like, I don't know, you're creating some like structure for yourself where it always has to be 1,000 frames, you can do that analysis with like, okay, here's a clip that is, 3 seconds long at 24 frames per second. Here's another clip, like add them together until I get to 1,000. Let's check on if that video finished. Still running. I think I know why that is. So one of the funny things you'll see here is like the larger you make your video, right? We're making our video much larger. We're making other small videos larger. Just means it's going to take longer to process. So the size of your video file will determine how long it takes. Right on time. It just finished. Let's download this. Also, that video is about triple the size because it is much larger. All right, after this, we're going to take a break and then we'll jump into looking at color. That's why I don't usually teach this class live, because there's always long times to wait for files to download.
Is it due to the bandwidth or due to the limitation of the machine?
Probably both. It's actually probably more Google enforced limitations. Like I think I mentioned this before, but downloading files from Drive is faster than downloading from Colab. I assume there's like some reason or like they've forced that into Colab. But it was easier for me to save this directly to Colab. So, and I'm not going to keep it. Probably also has to do with our network speed. I mean, downloads should be less affected by network speed.
But we can see the RAM and
that's processing of that's when we run a cell, that's actually processing of the files. Yeah. If, like I was mentioning, if you're working off 6K or 8K video, you'll likely crash RAM because trying to load those large of images into a machine like this will be too much for it and it'll crash.
People need higher RAM. I started working with this tool called RunPod recently.
Yeah.
And you can run Colab on it on much larger GPUs.
Yeah.
And it's pretty easy to get set up.
Yeah. Yeah, RunPod's good. There's a couple of those like that where you can rent other people's GPUs and stuff. Yeah. Let's take a look at this padded one. So again, remember, this is a much larger video, right? And you can kind of see even as we load it, it's much larger. And what we've done here is we've actually padded out our video. So you'll see bars left and right, or top and bottom. You can see that this is probably the actual dimension of our video. Let's just quickly scrub through this. Yeah, so we'll see, it adds top and left. So here's a case of where I grabbed a trailer off YouTube that's clearly much smaller. And what it did is it actually just kept it at the same resolution. It didn't upscale. And again, that's probably just depends. I mean, this is sort of like, for me, I would do this if I wanted to highlight that I had video of different dimensions that I scraped off the web or whatever. Not everyone would want to do this, right? Most people would try to like get it to like, letterbox, but like keep the same resolution. Whereas I kind of like exposing that. So here's another case of a video that's pretty small. This is what padding is do. There is another function somewhere that just does letterboxing, where it does, I believe, scale down to this minimal dimension and then add letterboxing to that. So those are all options for this. Okay, let's take a quick, can we do a 7-minute break? So be back here at 1:35. Cool. All right, so hopefully in the next hour I can get through this. I'm pretty sure I can. So we're gonna look at color, and color analysis is a part of this. So obviously color is, except for black and white films, a really key component of filmmaking. But also it changes dynamically, right? Like it changes over time. Whether it's a time lapse scene that is going from night to dark or day to dark, or whether it's, someone walking through a space, those colors are going to change. And I think one of the interesting things about is how to assess that. So we can look at using algorithmic tools to actually like assess color usage. So to talk about this, we also need to talk about color formats. I will not spend all day talking about color formats, although again, this could be a full lecture by itself. In general, especially with video or digital file formats in general, there's sort of 3 main color formats to think about. The first is RGB. This is generally what most video is actually in. And this uses red, green, blue color channels. This is called additive color, meaning if you add all these colors together, you get white, versus subtractive color, where if you had all the colors added, you would get black. So RGB is what most of our TVs and other tools actually produce. So, I think these TVs, I forget how they work today, but like they used to work where they had a single resistor that would display red, green, or blue. And depending on that value, you would get different colors. HSV is probably an easier human understandable different color channels. So HSV stands for hue, saturation, and value. Hue is what we call the color purity. This would be orange, red, green, blue, that sort of thing. Saturation is how much of that color is in something. So if it's very saturated, it's very bright. If it's desaturated, it's very gray. So you might hear cool gray, warm gray, those sort of things. That's sort of a combination of a desaturated value, but a change in hue.
Can you get all the same colors with HSV that you can with RGB?
No, let me show you that in a second. Good question, though. And value is lightness. So value is white to black. So those 3 combined get you each color. And then lab, which is a thing we'll look at in just a minute. This is actually what we're going to use in our process. I don't even know how to describe lab. We should just look at the chart for it. But lab is helpful because it's what we call mathematically equidistant. And this becomes a big challenge within our tooling. So the best way to look at these is actually look at these graphically. So here on the top left, you'll see we've got RGB, and that's additive, right? So when you add all 3 of those colors together, you get white. Versus printing, if you ever have printed a t-shirt or anything otherwise, like on an inkjet printer, that's what we call subtractive, which is yellow, magenta, cyan, and often black. And when you add all those colors together, you get black. We've got the HSV color space, which is actually like, again, you'll see at the top is sort of the, RG, or like the Roy G. Biv color palette, essentially. Saturation determines how much of that color is in it versus how gray it is. And value is black to white, essentially. If you made saturation all the way down to the left and you made value all the way to the right, you would get white. So these 3 have an interplay with each other. Now, here's where it gets weirder or trickier is also color spaces. Color spaces allow you to, different color spaces have different accessible colors, essentially. This is so confusing. It's almost like not even worth describing here. But essentially, often, if you do high-end video production, you're asked to work in a certain color space versus most web materials are made in sRGB. You'll see that sRGB is like much smaller color palette. You can't get these really vibrant greens or these really vibrant blues or these really vibrant magentas in this sRGB space. But if you work in Adobe or other color spaces, you can access those. It's almost not even worth really debating because most of the video we're going to be working with here is sRGB. Yeah, go ahead.
If it's not even worth talking about.
No, go for it. Yeah.
It seems like so arbitrary that we'd be like, oh, we have these colors, but if you want, we can have more, like, I don't know, like, why?
So it's basically
be such a small range.
Cost, technology, whatever. So like today, the new Apple monitors have like, they're probably like more that pro photo RGB. Better resistors and better like LEDs, like all that stuff just makes the range easier to achieve. Whereas back in the day, on a cheap desktop computer, like no one really cared about like having really high-end colors. So they all defaulted sRGB. Also, like, back in the day on the internet, like you had smaller bandwidth, so it was easier to compress your colors into a space that made sense. So, I mean, again, it just gets so complicated. Like this is really where, like, if you're going to work on an exhibit or like an installation, like you might care about this, but with like web video, it's always going to be kind of shitty, lowest common denominator sRGB stuff. Where it gets interesting actually is in lab, which I can't really, mentally, it doesn't really make sense, but the idea is that there is L, which is our luminance channel. That means how white or how black something is. Then there's an A channel, which determines green to red, and then a blue channel, which determines blue to yellow. The reason that people like working mathematically in this space, you'll see it as equidistant, meaning everything here is like relational to each other, whereas with HSV, this is often determined in what we call degrees, so it's 0 to 360, this is 0 to 100, or this is 0 to 1. Like they're just like, it's really hard mathematically to figure out your space. Whereas lab tends to convert everything into a space that is easier to manipulate. So actually when we do the stuff we're gonna do today is actually be done in lab. And there are ways to convert these colors. It's all really high-end math or like really theoretical stuff that I don't really think is necessarily important in this class. The only thing to know about the reason that lab works is we get better colors out of it in terms of what we actually get as a result. So that's why we use it. You probably have seen stuff like this. Like, this is a website called colorpalette.cinema, where people will just go in and assess colors of various films. Again, it's all about like mood boards and oh, why do I like this film versus this film? Is the way they use color, that sort of thing. We're actually going to basically build these today using k-means. So we'll look at a clustering program that will basically generate this for us. But we're also going to look at emotion. So we'll look at how motion affects these things. But if you ever want to build one of these, you can use this tool to basically do it for you. Here's a cool video. It's 24 minutes long, so I'm not going to show all of it, by a designer by the name of Irma Boom. This is called Art Barcodes. And this was basically taking famous paintings and breaking them down into colors, color analysis. So this one's obviously a Joseph Albers piece, but then what is this one? So it's a Basquiat. So there's different ways to do this. Again, we talked about static versus video. You could easily apply this to static images. In fact, that's actually what we're going to do. We're going to take static images, take every frame of our video, and then reproduce it. So this is a cool little video if you want to watch it. It's definitely meant to be more like an ambient thing that sits in your office or whatever. But I think it's kind of interesting to see how it's applied and how it works. So we're going to use a tool called k-means, which is a clustering program. Has anyone used k-means in here before? I assume the data science people have, but it's actually quite helpful for what we're going to do in this process. Let me talk a little bit about what k-means is, and then we'll actually show how it works. So k-means works by defining a number of clusters. So it basically says, in this case, I want 5 colors from this palette. And then what it does is sort of like randomizes where those clusters start. And then over time, it learns to move clusters into the best scenario. I think the best way to describe this is actually just showing a video or a GIF. So here we start by randomizing our clusters. And then over time, we determine what clusters make the most sense. Right, so over time, it learned that top right corner was all green, or that cluster. But it starts by randomly, you'll see the X's, that's where the randomization started. And then over a certain iteration period, it moves to the right space, or it figures out what the best clusters are. Now, obviously, you're seeing this in an XY plot. That's partly the reason why we want to convert all of our stuff to lab, is so that we have 3 dimensions. We've got an L, an A, and a B, and we can do 3-dimensional cluster analysis. That's essentially all we're going to do. So it's going to take our colors, convert them to numbers, and then try to find the best clusters for those colors. And as I mentioned, it turns out that lab is like the best way to do this because of that equidistance. There's a couple of good examples here of basically someone walking through the process of starting with RGB color, assessing on RGB, and then showing why lab works better. I want to say this one might be lab, and this one might be RGB. There's slightly, no, this one is RGB. I think we want this redder, or sorry, this one is RGB, this one is lab, and we get this brighter color, which kind of maps better to these reds here, right? So when you do RGB, you tend to get a little bit more flatter colors, and stuff like these spikes might not really be represented quite well. So that's why we're just going to use lab here. The other thing we're going to talk about is we always want to use really small images. If you operate clustering on, basically this is every pixel has 3 dimensions to it. So if it's a really large image, it's going to take forever to do that clustering because there's just way more points it has to think about. So in most cases, we're going to downscale our images to be very small. We might lose some detail in that, but again, because we want the major color clusters from it, we don't really care about that. So that's the other trick, is make sure you generate small images. Last thing I want to mention about k-means is it's what we call non-deterministic, meaning that GIF we saw here, that very first step is randomized. So it just puts an X in a random spot. What that means is that every time you run this process, it'll be slightly different. So even, here's an example here of like a couple of film stills from a Stan Brakhage film. You'll see that the difference between these 2 steps, now this is actually a slightly different film step. You'll see this is a little bit brighter. You'll see how different the steps are between each other. That's probably actually due to the randomness and not necessarily purely the frame itself. So you'll see like these 3 frames look pretty similar across it, but we get different colors, and that's because of that randomization process. There's some ways to work around this, but in general, like this is kind of one of the downsides of this tool, is that it is random. And because we're running it over a series of images, we might actually we'll get a lot of noise in that. And I've got some ways to sort of get around that, but it's just a thing to be aware of, is that these animations will look quite noisy because of that experience, because that randomization process.
It could randomly differ in how it analyzes one image, but if you run it on a series of images,
Well, in the way that we run this, it's going to be every frame we start from 0. So every frame we sort of like randomize the process, meaning it's going to be a little bit noisy. You could, I guess, in theory, take your previous frame's positions and run that on the next one and hope that it only changes a little bit. The downside is that I would imagine in most video, you would actually get, it wouldn't actually change enough for the clusters to catch the change. We could play with that and see, but in general, yeah, like there's different ways you can approach this, and they're all going to have pros and cons. You have a question?
Yeah, I'm just curious how, like, it seems like it's the colors getting like quantized to certain like colors, I guess.
Yeah.
Like, how does that work?
I think it's just the clustering. The clustering will tend to gravitate towards like a certain averaging color, right? Like I would say like this color might not actually exist in this set, but it's sort of averaging toward that value.
I see. So
Yeah.
you have set labels.
Right. It's just taking the RGB values and saying, based on this cluster, I think this is the closest grouping of values. And that value is centered here, even though that value might not exist in the actual image. Yeah. Yeah, it's not a perfect process, but it's like, it's helpful in that it's algorithmic and it does it all for you, or like gets you a starting point, right? You might need to tweak it from there. The other thing to know is like, you got to make sure you don't have letterboxed videos in your video file. So sometimes you might download a video and it actually includes the built-in black bars, the built-in letterboxed values. That's going to obviously become the dominant color if you have huge black bars in your video. The other thing I should mention is like, this is actually going to give us like a score based on usage, or like based on how much of this, it's going to show us a dominance scale, right? we could flatten that, like in those screenshots I showed from like that Instagram channel where they just showed just like video a color palette from a still from a video. But we could also use this to leverage like, hey, what's the like, the brightest color, but like doesn't always have to be the most dominant color. And that's kind of what's interesting here is this will actually give us an array of different colors to play with. In a lot of cases with film, like in cinema, black is going to be the most dominant color because that's how a lot of stuff is lit. So a lot of stuff is lit to have a lot of black in it. So when you're in theater, it's like the brights really pop, but there's a lot of black in it still. So one of the things we're going to look at as we play with these tools is like, you might not actually want to operate on your first color value in your array, because in a lot of cases, it's either going to be black or white. So you might actually want to operate on your second channel or your second iteration, because that's where the color might be. And this is where you kind of have to, like, again, there's like the pure mathematic way to work on it, but then there's the artistic way, which is like, what do you actually need to get out of this tool? And in this case, it might actually be more this, or in some cases, it might be like, what's the like 10th color, right? Because that might be the brightest, but like almost when I was in design school, we call that the spice color. That's the color that like is just a little bit, but it like stands out the most. And you might want to operate on that. So there's different ways to use these tools to get what you want out of it, but knowing that you're going to get, well, one, you define how many clusters you want, right? So you could say, I only want 3 colors, or I want 10 colors, and it's going to give you back those values. But then also, what is actually the importance of those colors? Is it that I want this, the brightest or the most dominant, or is it more that I want like the flattest and the most mute, that sort of thing. So you still have to do some operation on that, even from there. This is a video, we'll skip this one. There's a video that sort of applies the same process to a video where I sort of like took the background color of every video and then sequenced it across RGB. So there's different ways to play with this. Again, this is sort of using k-means, but really sort of pulling out the brightest colors in each, or the most unique colors, which would also be an interesting way to work off that. So once we have RGB colors, we do need to convert it to, okay, so this is like, once we've got those clusters, we can also look then at HSV to maybe tell us if this is daytime or nighttime, right? So because all these colors can be interchanged with each other, you could look at something like the value, which is black to white. You could say like, how black is this scene? How white is this scene? And work off that as well. So we'll look at a little bit of this as well, but once you've got those clusters and they're given to you as an RGB value, you could easily convert them to other values like HSV and then work off that. So I've got a little bit in my notebook here that will actually look at how to do HSV sorting. Because HSV is what our brains sort of operate best off of, I find that often converting these back to an HSV value means we can then play with them, right? We can use that value to get light versus dark, or we can use the H channel to actually get what color it is, whether it's red, green, blue, that sort of thing. So let's take a look at this notebook. Oops, actually, I already have this one open. So I'm just going to switch over to there. And let me just share this with everybody in our channel again. Okay, so the first step we need to do here, unfortunately, is we need to convert all of our clips to frames. This is going to take quite a lot, and honestly, especially for those of you on small drives, small drive space, this might not make the most sense. So we may want to look at actually, I'll figure out how to download these notebooks so people can have them and work locally, because it's probably gonna be better to work locally in this case. But let me just grab maybe one file here and work off that. So let's go ahead and take our clip path here, and we'll just work off of one of these folders. And I'm just going to save this. I mean, the other thing I would say is actually, so I don't know if I explained this yet, but the way that these folder structures work is if you're not in Drive, you're saving this to what's called the Colab instance. The Colab instance tends to have a decent amount of disk space. So this has 225 gigabytes of disk space. If you just want to work like in a session and then you don't want those files ever again, you could save this to content, and that would save to this space, which will obviously be larger than your drive space, as long as you don't mind not being able to keep those after you're done, right? So you could save to there. do all your k-means clustering video files, and then like just dump those frames once they're done. So that's what I'm going to do here, just so you can see what it looks like. But that's basically the process for that. And while that runs, I'm going to go ahead and do this. I'm actually going to skip over some of this. If you want, there's a whole video like that describes all of this step by step, linked to here. But just because I've sort of already explained that RGB isn't the best space to work in, I'm going to skip over the RGB step and just show you the lab color. So here's a good example of like, this is RGB, which isn't terrible. But you'll see that the lab space is a little bit like these colors are a little bit more differentiated, a little bit brighter. Yeah. So we'll look at how to do this in just a minute. Once this is finished here. The downside of this process is that this takes quite a while. Converting all these to frames is like not the fastest process. Let's see how many we've got here. Oh, we're actually moving pretty quickly here. So what you'll see is that as this creates frames for each one of these, it is going to give us the steps of, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way through our clips here. Let me see if I have the examples for this here, because I think it might be better to sort of see this as an example. Yeah, here we go. Okay.
They're a benefit. It's not my.
That's not exactly what I thought it was going to be. Okay. We'll just wait for a minute then. All right, let's run. Let me just also say, like, I recognize I'm running through some of this stuff quite fast. Part of that is because I assume not everyone is going to be interested in every topic. So if there is something that I run through really quickly that you are really interested in, like, please feel free to DM me. And if you're like, hey, I need that a little bit slower, or I just have more questions, like, please, I'm happy to set up more time to talk about those. I'm sort of set up this class more as like a survey to sort of see all the potential options that are available to you, while also recognizing that you won't have every week, or you won't have time every week to work on everything. So I'd say like, just sort of find what you're really interested in. And if you want to play more, like, I'm happy to set up time to talk about that with you. How many clips are in this folder? Oh, damn, that's quite a lot. Okay, let's stop it here and let's hope that that's enough for us to work off of. Okay, so with that, I think I've got 55 scenes. Okay, that's enough to work with. So what we're going to do here is we're going to run the first cell, which will just save out a bunch of our functions. And then we're going to start with is we're just going to look at individual images. So we're only going to process this on a single image. just to sort of compare the two. So let's actually find a scene that maybe has some good color in it. That one's not terrible. Actually, that's good. We've got some blues, we've got some reds. Sorry, it's a little dark of a concept. Let's find something that's not suicidal. Good color, bad content. There we go. That's better. Okay, let's work off that one. I think I did that last week too, where I was like, this one looks good. I was like, oh shit, it's someone killing themselves. Okay. Good color here, right? You got some yellows, got some reds, got some blues. Let's see what actually gets pulled out of this image. So what we're gonna do is we're actually just gonna copy the path here from this one. And we're going to paste that in here for the file. So that's our file path. And then we're going to say, how many clusters do I want? Let's keep this a little bit small. Let's go 5. So what it's going to do is it's going to do our cluster analysis, and it's going to spit out, based on the RGB space, what the colors look like. Now, I should also mention, this is actually quite a large image. This is 1080. I think we actually scale it down let me see if we scale this down. I don't actually scale it down here. I scale it down another place. So look at what happened to our colors. Remember that this was this image. So because we only asked for 5 clusters, it really only gave us this sky background, black again, which black always ends up being the thing. Maybe the building, and maybe like a little bit of this car hood, I guess, maybe. If we ask for more colors, let's try and run this again. Let's say instead we want 12 colors. Actually, I made my own mistake here, is that there is some letterbox in this. So we've got our black bars. Not terrible, not the end of the world. But that's probably also influencing our analysis here.
Would you manually have to remove that?
Probably, yeah. I would do it on the entire trailer, and then do the Piscine detect this thing there. Okay, so again, remember that we're working in RGB space. We do finally have something that looks reddish, but it's more of a brown. It maybe is more like her shirt than the red. But this is part of the cluster analysis, right? We say, hey, we want only 12 things. The cluster analysis might be moving the red into the brown because it's sort of a similar tone. So therefore we get this. Now, the other thing is we're working in RGB space, which I told you is not a good idea. Let's look at it in lab space, which is the next one down. So we'll copy this path. We'll go down to the lab color space, and we'll do clusters of 12 again. This takes a while because I'm actually operating on the entire like full size image. Further down in here, I'm absolutely certain that I've got a way. I'm doing something where I'm resizing it. Yeah. So when we actually run this process on video, we do resize it because it would take forever to do this on every frame one by one. So here's what happens when we run this using k-means. And I would say actually that red is much better for us, right? That red kind of is, again, maybe a combination of these two, but it's a little bit brighter. And if we compare this color palette to this color palette, sorry, no, that's kind of hard. We're just bouncing back and forth. But I can already see that I get a little bit more of a distinct, like everything feels a little bit more contrasty. Everything pulls away from each other. And I think that's why people use lab a little bit more. Because of that equidistant space, you get a little bit better range between your colors. And if you were to run this on more and more iterations or different images, you would probably get different and better results. So what we can do from here then is we can actually output this color bar. And the way to do that would be, again, to pass in our frame. And then our content. So we're going to save this directly to our folder here. This folder here. And then let's just do this again. This is going to save out an image. And I believe that image will be the exact dimensions of our input frame. Yeah. So I believe I've got somewhere on here. Where would that be? It's got to be on my video channel. Okay, we're going to look one more place and then we'll call it a day. If we can't find it, I'll share it later. Yeah, cool. Okay, so this is a video using that exact process. So the top is a video by Stan Brackage, and the bottom is our color analysis. And you can kind of see it's not, well, first off, the video itself is not like a seamless, sort of loop, but you'll see it still bounces a lot, and that's that noise that's in that process. But what we did here, or what you can do here, is you can take these outputs, right? You can run this across an entire folder, and then you can recreate video. So basically all I did here, I don't have the actual steps here. I can probably include it for anyone that's interested, but we do the folder processing that generates an output of our k-means. I then turn that into a video and then stack the two videos side by side. So if you wanted to see sort of what that looks like in your individual images, you can do that. So for example, this is also, so another thing to talk about, sorry, very confusing today. One thing is we can do this on an individual image, which will give us every frame, right? The other way we can think about doing this is, let's say we combine all of the frames from a single clip and then do k-means on that. And that will essentially give us the cluster analysis for that clip. Because cluster analysis is not position dependent, all we really have to do is create a stack of images and then run k-means on that. And that will still give us the cluster analysis across those entire sequence of images. So this is done frame by frame. This is done clip by clip. And obviously I think it's like a 2-minute long video or something. But this will actually switch over at some point, maybe that's an image. I'll find the sample and share it with everyone, but there is a way to just do cluster analysis on the individual clip as well. And that's what's listed here below, I believe. Oh, this is actually, sorry, this is the actual video where we create that cluster analysis. So we'll process every single frame of the video. So we'll turn everyone into a single frame. Then we will process every frame using k-means. Do I resize here? Oh, it doesn't look like I do. I really need to fix that. Okay. This is essentially the process to do that Stan Brackage analysis. So if you want to follow that, you can here. This will probably be a little bit slow because of the scaling issues, which I'll probably look at. Let me look at that this week and fix it and let people know when I've made updates to it. But if you want to run it now, you can. It's just going to take a while because you're going to run it on every single frame at full size, which is going to be slow, but that would work. And then this shows you how to actually stack those videos. So I do actually have the code to actually stack everything. And again, this is actually all described in this tutorial video here. So if you want to walk through it step by step, you can. I just know we're running short on time, so I don't want to walk through every single thing, because especially this will take a while. This process here will also then let you run it on every single, or sorry, this will run. Let me make sure this is correct. This runs on an individual scene. And what we'll do is we will actually convert this into frames manually. So if I were to take a new frame from a new video clip from here, let me just grab a video clip. There we go. Okay. So if I feed into this video, I'll process the entire clip. So what it's going to do is it's going to take our clip. It's also going to convert this to frames, but the difference is that this will not convert every single frame. It will only convert, like, I think every 12th frame. So this will just pull out just a handful of frames in our video, stack them all together and create an image from that, and then apply a k-means to that grouped video, if that makes sense. I feel like everyone's staring at me like this doesn't make any sense. So let me try to figure out how to visualize this. So well, actually, let's just run this. Let's run this and I'll show you what ends up happening there. So let's make this a little bit higher. Let's make it 9. No such file or directory. Okay. Okay. I see what's happening here. It's looking for okay. So I screwed up the way I did this. Okay, let's go all the way back to our first step here. So the challenge here is that this is going to look for a set of, the way I wrote this code is it's going to assume that you did your frame outputs in the same place you did your clips outputs, which I did not do. So let me fix that really quickly here now. I'm just processing one of these. So ITP. Okay. So what it's going to do is it's going to look for a clips folder. I'm going to sort of hack this. So actually, you know what we should do? Sorry, I'm thinking on the fly here, and this is very messy. I'm just going to change the paths. I think it should work. Sorry, give me 1 second here just to change some code here. So we got it. Also, like, is there even a building there? Like, I guess there is a room there, right? Yeah, I guess there's a classroom right there. Yeah.
We think it's 9, like where they build all the crazy musical instruments.
Okay. Okay.
Yeah, like 100 girls. P5 sound.
Tacky, but let's see if it works. Nope.
I think you're cutting off that piece.
No, I just input the thing wrong. Okay, so no file there. Why is there no file there? That's incorrect. Ooh, okay. Getting closer. Okay, that worked. Okay, that worked, but that's janky as hell. So essentially what we're doing here is I'm just going to download some of these images. Okay. Let me just talk about this a little bit more because I think theoretically it makes more sense if I show it to you how it works. So, okay. So what we were doing previously is we were just operating on every single frame, right? We were doing k-means on just every frame. Now, the problem is because k-means is non-deterministic, every time we swap out a frame, we're going to get a slightly different clustering system, right? It's going to recreate, and it's going to do another randomization. We're going to get slightly different results. What we can actually do instead is, let's say we want to do clustering on the entire video, but the way that clustering works, it still expects a single image. God, Jesus, really? Some other applications here. Of course, why wouldn't? No, it's because my computer is full of crap everywhere. That's why I have terabytes upon terabytes sitting on my ITP Google Drive. Okay, let's just think about it this way. Let me just do this then. Jesus Christ. do Photoshop the old-fashioned way by dragging it into a slide. So what we can actually do wow, now we're getting to chanting. Jesus, okay. Almost there. So if we want to get a cluster analysis over the entire video, what we can actually do is we can take every 12th or 13th frame, stack them all together, and then use that as the image. So we feed this image into k-means. K-means then look, because k-means isn't deterministic by position, it just looks at the color values, right? So we then cluster across the entire image, and that gives us an analysis for that clip. So that's essentially what that other, what I just spent a long time doing. That's essentially what this process does. This process will connect your clip path to your frames that we created, and then generate a cluster on that entire video, or that entire video clip, essentially. So that is the cluster for this stack of images. And that kind of makes sense, right? If we look at that, you can kind of see that like dull, flat tans and blues.
You're reshaping it into, you're working in 2 dimensions still when you run K-means?
Well, we work in 3 dimensions because lab color.
Okay.
Yeah. But it doesn't, it actually, again, it doesn't matter whether your images are stacked in a grid or in a long row. All it cares about are the colors.
Okay.
It doesn't really care about X, Y coordinates. It cares about what the LAB variables are for each pixel.
Okay.
So you could, I think what I actually am doing is just making a long strip, and that works fine. Yeah, doesn't really matter. Yeah, so all you're doing is you're sort of combining all those images. That's what this thing does here, is it combines all the images along one axis. Yeah, and then you just run, but I am also then resizing it to save us some sanity. This looks like I'm making it like a 15% of that image, or of that size, and then using those pixels to actually do the k-means clustering from there. Yeah. So what you can then do is then you can operate this on every individual path or every individual video, and that will then give you sort of a HSV value, or sorry, a collection of RGB values by array. So if we do this in this session down here, this is where it gets really annoying. I'm gonna have to do this again. Maybe not, let's try it and see what happens. I think I can just cut and paste these 2 things here and see if this works. So this time what we're going to do is we're going to grab our JSON file. We're going to paste our JSON file up here. Then we're going to give it the path to our video clips, which is this path here. And what we also need to then do is give it one more variable, which is our frame path. This is all because I had to get fancy and try to save this in a different location. Clips path, so I think we want, let's see if this works. This might not actually work because I think it's going to try to pull from the JSON file. Might get a little messy. Let's see, output content. So let's save this to
I might have missed this, but where does the JSON file come from?
That JSON file is the one we've sort of been iterating on multiple times. So you're going to make it when you do the, there's actually that JSON database notebook from last week. So that's going to initially make your JSON file. Then you're going to update it again when you use the one we looked at previously, which was that FF probe, which was going to pull from there. So yeah, so you'll sort of continually update that as you go through each one of these steps. Yeah. Content frames. So this last step, I'm probably going to need to rewrite this notebook a little bit because it's not necessarily very well thought out. So I'll have to rewrite a little bit of this. I'll do that tonight. What this is then going to do is actually going to process every one of our videos that's included in our JSON folder. And it's actually going to then give us the cluster values for each one of these. And it's going to save that back to our JSON file. So everything above this is just cool, like visualization fun, like being able to generate a visual and like produce a video from it. This actually saves that data back to our JSON file in order for us to use it in the future. So let me actually make some updates here. Does this actually write it to our? Yeah, okay, this does. Okay. So again, this process does take some time. So I would probably recommend not starting tonight because I'm gonna need to rewrite this notebook a little bit, but starting, as soon as you can. I'll let people know in our Discord when it's actually finished and I've rewritten it a little bit. The challenge here is that because I was saving the frames in a different location than I was saving the clips, I had to rewrite some of it to be a little bit cleaner. I'll need to rethink how to do that in a better way, and then I'll provide some instruction for folks, but I'll do that tonight so everyone has it. Now, when this finishes, it's going to give me an error message here because I couldn't find the video. So let me do this. And if we go back to our JSON file here, let me download this. We load this back into our prettifier. you'll see here now that we've actually saved a bunch of k-means colors. And these are RGB values. And this array is set up in the order of predominance or dominance, I guess, of the color. So we've got the k-means colors here, meaning these are the RGB values. And then we've got the weights, and these are how important each one of them is. So this should all add up to 1. So we can then take this process and we could then, in the future, we could go through every single clip and say, only find the colors or only find the clips that have a color within, I don't know, the range of like something blackish and a weight of, 20 of higher than 0.2, right? So we won't get to that this week. We'll sort of look at that over the next couple of weeks of how to actually operate on this data. But because we've started to store all this data, we can actually begin to use it at a later date. So this is going to just create a channel of like, we're going to capture all the weight, which means, how important each of these colors are. We're going to capture the RGB values. And then there's actually another step further down here, which if we feed that JSON file back into this, this will also convert that to HSV. So let me download this again. Look at it in the prettifier. And now we also have HSV values. So remember, HSV values are values that are easier for us to operate on. I mean, they just make more human sense. We also notice that the ranges are different. So these colors up here, you can clearly see that these are RGB because they're more than 1.0, right? So these are actually like 0 to 255, whereas the HSV values are 0 to 1. It's kind of an easy way to sort of like be able to tell when you're looking through these, but they're also keyed with HSV here. I should probably key these with like an RGB value or something. So what this means is that over the next couple weeks, we can even begin to look at how to sort these. So when you run this later selection here, so this code will allow you to then grab based on the index. So we created a cluster of 6 different colors, right? I think that's what we set up here. Yeah, we said the number of colors is 6. You could create more clusters if you wanted to for your particular file. I think 6 is like a good number because you get some big ones, you get some small ones. So by using clusters of 6 there, we can then ask to say, hey, I want to sort my files by hue, and then I want to use the 6 color index, right? So I want to use the 6 color versus the first color. Remember that first color more often than not is going to be black. So I'd probably always skip that first color and maybe say your index of, where did that just go? The index of 1, which would be your second color, right? So your second color, and I want to sort it by hue. And then what this will do is it'll spit out all of your video clips in the order that you want them to be in. This next cell would then do that concatenation process we were doing before, which would recombine them based on that sorted level. And that's what is linked to in these example outputs here. This is a single clip, a single trailer that has been broken up into clips and then resorted by certain, this one is sorted by a value, this one is sorted by hue, and then the index of those colors. And I think what I kind of found was that like index 1 sorting by hue tended to generate sort of the best results. I'm kind of nervous when I take tests. So see here, this is very red to begin with. And then we get into blues and greens. What is going on there? Yeah, so back to reds. One thing you should know is that because these cycle, your first and end videos will actually you could kind of loop them because your first and end will, at least in these cases, be red. And then everything in the middle. What's that?
I'm kind of nervous when I take tests.
Oh, sorry, for HSV. So for V, actually, this isn't true. This would be for hue. Thank you for, that's true. For hue, oh, this is hue sorted. Or maybe I linked to the wrong video. Shit, it's the wrong video. It may actually be the wrong video. Let me find the right one. Let's say, Vimeo search has gone to shit recently. I will find the right video and make sure that's linked correctly, because I bet you that's the wrong video. But yes, hue should be cyclical, meaning hue will start at red and end at red, whereas value will be light to dark, or dark to light. I need to look that up, what direction it goes in. But but this is like, this is our first step into being able to use that data and do something with it. So sorting based on that. So let me spend tonight just cleaning up this notebook a little bit, but the other notebooks you can start on now, right? So the other ones you could start with duration. The one thing I will say is some of this stuff is like, you could skip this analysis. The FF Probe notebook, which it gives you the duration, the dimensions, and the FPS. You can't skip that one because we're going to use that like all over the place. So I'll write this up again in the Discord as well, but like essentially the steps for each one of these is find a video you want to use Piscine Detect to break it up into pieces, use the JSON database notebook to convert that data to a JSON file. Then you're going to use FF Probe to pull all the dimensions from it. And then from there, you can kind of pick and choose what you want, what notebooks you want to use. So what I might actually do, maybe this will make sense. Maybe I'll actually just pull all 3 of those steps into one notebook and share that with everyone. So they've got that as like, this is the thing you must do. Then everything else is optional once you get there. So I'll do that tonight as well for everybody. I think that'll be helpful. Like, must do this step, and then the rest of these are optional. So we can sometimes, I mean, if you are not interested in color, don't run the color analysis one. When we start talking next week about object detection or body detection, if you're like, I don't care about any of that, all my videos are abstract, you can skip that one. Basically what we're gonna do is build a little JSON data set that contains all these parameters. But if you don't have those parameters in your stuff, then we're just gonna ignore it in the future. So it'll kind of be up to you to decide what you wanna do with your data set. Sound good? Okay, cool. We did not get to shot detection, but that's fine. I'll cover that next week. Man, I'm gonna have a lot to cover next week. All right, let's try to get here exactly on time next week, because I have a lot to cover. I'll try to figure out how to make it like sort of like worth our while, and hopefully I'll also make sure there are no bugs in our the way I run this stuff next time. But yeah, so next week we'll look at actually like figuring out what's in our scenes so we can add that to our database. Cool. All right. Yep. See you next week. And again, please feel if you run into issues, please feel free to hit me up on Discord. Happy to help. Yep.
I was wondering why it's dark on here. For when I'm trying to update a JSON database.
It might just not. I mean, there's no output that says it finished. It's just sort of like loads it and then it finishes it. So it might actually be okay. Like if we just go, this is this one.
Oh, the text one.
Test one. Okay. See if that's true.
I'm actually asking, but I know the answer.
Oh yeah, but you're not saving the path here isn't a test. So you're overwriting it to this one. So if you wanted to save it there, you would just want to add test here at the end of your file path. But if you double click here,
yep,
you're still not getting anything. Okay, interesting. Let's see. What is this?
It's just a video.
Yeah, let's see. Let's run it and see. Oh, okay, here's why. So we need to actually run the first notebook, which is our where is this one? This is why I'm gonna, sorry, is that correct? You want to open that? Yeah. So this is why I'm gonna combine all this stuff into one notebook so it's a little bit clearer for everybody. You have to run this one first because you have to make your video file Like it needs to create the object for all the video files here. Then when you run that other one, it's going to look
That's
through
why,
that. Yes.
because
Okay.
I was
Yeah.
trying to look for that JSON file
Yes.
all
Yeah.
the time, and I cannot find it. So I just okay.
So this week I'm going to combine all this into one step. So it's like this is the must do step,
Mhm.
and then this is the
got it.
yeah.
So the JSON file are just basically the database we create for our videos.
Yeah.
Okay. So we're not creating them manually. It's just through those code.
Yeah.
Got it.
Yes. Yeah. Sorry about that. I know that's confusing. That's why I'm going to fix it. Yeah. Cool. Hey.
Were you suggesting that we should like develop our final idea as soon as possible? I wish to have better, but there's a general question that is I'm not sure about how technology can do for us.
Yes. Yeah.
Like what's the maximum, what's the potential of it?
So what I would say is, I mean, obviously this is 7-week class, so we can't, I don't think you'll get to a final project. This is just kind of me showing you a bunch of stuff.
Okay.
So what I would say is if you watch, there was that video linked from
In your artificial image YouTube channel.
Yeah, so if you look at this, what was it? It was this one, the Scream Scenes Director's Commentary. That'll sort of show you all of the things that I've done with this tool.
Last month I did this crazy project where I did a new experimental video every day.
And it'll kind of show you like a bunch of options.
All around this theme of horror. So what I did is alongside my friend Tim Moore, we created I think something like
No. I mean, it's an old video, but it's linked to
like
from
3,600 video clips of
This one.
both
Actually, let me
screaming
just
from
highlight
various
this one.
famous films, famous horror films,
So I'm not
or other
saying that
fear
we
sort of
should go
scenes.
big
And
on, but
then for the
I
month
wish
of
this
October,
could be-
every day I took
I
sort of
wish
like
we
a
could
sampling of
learn from
those
the doing.
pieces.
Yeah.
And did something different
I
with
mean,
it.
it's
Sometimes using
actually
AI
necessary
tools,
for
sometimes
us
using
to do a
some
little
sort of
bit
big
project.
data,
Yeah.
you know,
You don't have to be
processing
it doesn't
tool.
have to be so big, so great, but it has to be like apply everything.
Yes.
So thank you for the answer. So I was trying
Yeah.
to see how this technology can do for us.
Yep.
And it's the 5th week that we're going to talk about the generative content,
Yes.
right?
Yep. Mhm.
Okay.
Yep.
So
Yep.
we should start from that week, I think,
Yes. Yeah.
because I think that would be in the core where it's clip to make up a video. I think the technology to generate something that to our needs is so important.
Yes, exactly. And I think that's sort of what like I realized I haven't previously taught the class where we do generative video, in part because generative video is pretty new. But yes, that is sort of what we'll end up doing is we'll end up merging some of that with our own data set of materials.
Okay.
So we'll have like some artificially created video, we'll have some found video that we have pulled from other sites, and we'll kind of mash them all together.
Okay.
Yeah.
It's like an aggregation of all the video
Yeah.
clips that we are having.
Yep.
Okay.
Yep.
Great.
Mhm.
Thank you.
Cool. Of course, yeah.